Welcome to AutoSens and In-Cabin, the world's leading communities for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information to connect the global community of scientists, engineers, and other automotive industry experts. We are joined today by Daniel Shwartzberg, Director of Business Development and Systems Solutions at Valens Semiconductor. Daniel, welcome back to AutoSens and In-Cabin. Good to see you again, my friend.
Hi, Carl. Well, thank you so much for the introduction. Yeah, it's really great to be back. Always a pleasure to talk to you, and thank you for inviting me to speak with you.
Of course, and I'm going to pick your brain here right at the beginning. As OEMs are looking to achieve these higher levels of ADAS on the road and then eventually to full autonomy, what are the key elements in the vehicle, Daniel, that need to be addressed in order for this to happen?
Yeah, I think that's a great opening question, Carl. I mean, yeah, we see a trend to ever higher levels of ADAS, and of course, the ultimate goal of the fully autonomous vehicle, it's called that level 5. And in order to get us there, I mean, we're going to need to put a whole bunch of sensors into the vehicle, right? We already see more and more sensors going in, even today at level 2 plus. But we're going to need to see more and more. And it's not just the quantity, it's going to be different types of sensors. And the quality of the sensor, the quality of the data that those sensors are yielding is going to need to increase as well. So we're talking about higher resolution cameras, we're talking about radars with higher accuracy. And so it's more sensors, it's better sensors, of course. LiDARs, we now begin to see those hitting the road. And more sensors, better quality sensors, and also the need for those sensors really to play together. So we're talking about the concept of sensor fusion, where we enjoy the benefits that each sensor brings, because not all sensors are perfect, right? So maybe a camera is great for daytime, but when it's at nighttime, you have some challenges, or if it's foggy, you have some challenges. So then we can make use of sensor data from other types, maybe from the LiDARs, maybe from the radars. And the sensor fusion that brings those together really gives us a great deal of visibility as to what's happening in the environment of the vehicle. So yes, there's a lot of emphasis, of course, on the sensors, but that data needs to be processed. And already we begin to see a very key and very strong trend in the industry of the move from a distributed architecture where you had a sensor talking to its ECU, its local ECU, shall we say. And we see the move into more centralized processing, maybe with domain controllers, zonal architectures, but ultimately to move all of that data from the edge of the vehicle into the middle for a centralized processing approach. And I was giving that compute element all of the information it needs in a raw way, removing the edge processing and doing it all centralized. So yes, a lot more sensors, better quality sensors, the need for the data for those sensors to work together. But of course, on the processing side, a centralized approach is where the industry is heading right now.
Daniel, the connections that we're talking about here, all these different aspects, what are the implications with regard to connecting all of these elements together?
So as you will appreciate, we are now bringing raw data. We will be bringing lots and lots of raw data from the edge into the center. And this is not just simple data. This is really highly important mission critical data, right? These are ADAS systems. Eventually, this is full autonomy that everyone's talking about in the future. This data has to be received very, very accurately. So not only accurately, but also a lot of it. So we're talking about very, very high bandwidth data links from the sensors to the compute, extremely robust. So we need to get that data received with no errors. And you will appreciate that in a very challenging electromagnetic environment that the automobile is, getting that data across reliably becomes much more challenging. But we need to get good data. Okay, if the data comes across with errors, now all of a sudden the processing element, the algorithms, they need to work harder to try and overcome the errors. So we want high bandwidth, we want highly robust links that the EMC in the vehicle, the EMI, those electromagnetic noises will not impact. And of course, we need minimum delay. So we need basically near zero latency from the sensor from the sensors to the processing unit, because any delay added, if we're thinking about an autonomous system, maybe an automatic braking system, any delay in the data reaching the processing and then an actuator being sent to do its work, any delay in that data increases, for example, the stopping distance of the vehicle. So high bandwidth, extremely robust data links, low latency, low delay. And of course, we would like to have a common link that is agnostic to the type of sensor. So it doesn't matter if it's a radar, a camera, a LiDAR. We want to have one type of link technology that suits them all. Now, of course, if I can also give you a standardized solution, which allows us to move away from kind of proprietary single source to a standardized approach, then that's even better. So there are a number of key technical requirements in terms of what the link is needed. And again, if it's backed up by a standard, then that's a win-win for the industry.
Valens has released the first A-PHY compliant chipsets on the market. Daniel, I think you know where I'm going with this, because no interview that we do would ever be complete without this next question. So tell us about A-PHY technology and what does it offer OEMs and the greater automotive industry?
Yeah, as you say, we've been talking about this now for a couple of years, because really A-PHY is a game changer for the industry. Okay, finally, after years of having to do this sensor connectivity with proprietary, meaning single source technologies, finally the industry has a true standard for high-speed SerDes connectivity within the vehicle. And standard is a good thing, because it means you can have a multi-vendor ecosystem. A-PHY comes to the world, shall we say, was born at the MIPI Alliance, which has more than 400 member companies at the last time I checked. At least there are just over 400 member companies, of which almost 50% already have business in automotive. So maybe MIPI began as a mobile phone, a cell phone standardization body, but it has very quickly also become extremely relevant to the automotive industry. So it's a standard not only by MIPI, by the way, the IEEE also adopted it, IEEE 2977-21. So it's a standard backed by the MIPI Alliance, 400 plus members, and all of the hundreds and hundreds of members of the IEEE also have access to this standard. So it's a standard opening the door for multi-vendor offerings, and we already begin to see that happening. So that's very important, and you just have to look at the chaos of the supply chain, semiconductor supply chain that occurred during the pandemic, and we're still trying to get over it, right? Proprietary single source are dirty words in the industry right now. Too many people have been burnt, so everyone's looking for a standard solution. And here it is, MIPI A-PHY. Now it's a standard. It's also a digital technology, shall we say? So the legacy solutions are analog based, if you like. Here we have DSP based, the digital signal processing, digital algorithms within the silicon, which allow us to run at very high bandwidths with extremely low latency and extreme robustness to those EMI, EMC noises, those electromagnetic noises I was talking about, right? So it's a standard, it's a digital technology. Another thing I should mention, because it's a standard, it opens the door for integration, right? Anybody who has access to the standard, who is developing, for example, a sensor, can now integrate A-PHY directly into the sensor itself. And if we're thinking about cameras, that means we don't need to put a serializer or transmit chip in the camera. We'll have the data coming directly off of the sensor as A-PHY traffic, meaning that the cameras can be smaller, lower power, less heat to dissipate, which is super important as these products get smaller and smaller. So it's a standard, it's a digital technology, it's a highly scalable technology. It's extremely scalable. So for example, whereas the first versions of the spec are up to 16 gig, already 32 gig is nearing completion, and there's a roadmap to go beyond there. So one technology that is highly scalable for the needs not only of today and not just tomorrow, but also years ahead in terms of the bandwidth requirements that the industry is demanding. It isn't asymmetrical data link. So what does that mean is while there's a single piece of wire connecting the sensor, shall we say, to the processing unit, we have a lot of data in the downlink from the sensor to the ECU and very little data in the uplink, okay? And that's, of course, what you want for sensor connectivity, right? The sensor gives a ton of data, high bandwidth data to the processing, and all the processor needs to then do is a little bit of monitoring, some control configuration. And that asymmetry is built into the standard from the ground up. And that gives benefits over, shall we say, symmetrical approaches to sensor connectivity, which are wasteful in terms of the size of the silicon and the power that the silicon therefore consumes. And finally, and I keep coming back to this topic of electromagnetic emissions and immunity, because it is such a critical factor in the industry, and it's just going to get more and more critical as we move forward. A-PHY offers unprecedented link robustness. We're talking about a packet error rate of 10 to the minus 19. Now, that is orders of magnitude better than the legacy solutions out there today. And depending upon how you do the calculations and who you speak to, but it's kind of, we're talking about, for typical use of the link, one error every maybe 60,000 years or 50,000, whatever. It's some crazy packet error rate, which basically means that this is an error, effectively an error-free link. You are guaranteed to get the data across correctly, meaning that the process unit doesn't need to, do too much heavy lifting to overcome errors and things like that. Standardized, digital-based technology, highly scalable, designed from the ground up for automotive, with really best-in-class immunity to those EMC noises I was talking about.
Speaking with Daniel Shwartzberg, Director of Business Development and Systems Solutions at Valens Semiconductor. Daniel, let's go a little deeper with this. How is the industry, or maybe asked another way, how can the industry further embrace A-PHY technology?
And I think you phrased that perfectly, because the industry really has rushed to embrace it right. We see a very, very big and rapidly emerging ecosystem of players who are bringing A-PHY product to market. And it is, how should we say this, an ecosystem that is broad as well as deep. And when I say broad, I mean it covers all of the various elements within the industry that are needed in order to bring a technology to market. So, for example, it's the silicon side, it's the chips that we are the first to produce. I mentioned that integration. Sony Semiconductor have already publicly announced, and we have already publicly announced interoperability testing, successful interoperability testing with Sony Semiconductor. They are doing that integration of A-PHY directly into the sensor, right? So all of that stuff I said earlier is happening, and it's happening right now. We see a very, very important announcement the day before CES from Intel Foundry Services, who basically have partnered with us to bring the next generation of our A-PHY compliant chipsets to market. And I think that's, if you look at that press release, and you can find it on the investors page of our website, you will see some very, very powerful words from the VP there at IFS, at Intel Foundry Services, saying that they're always looking for kind of best leading technologies that the industry needs, and that's why they are partnering with us to bring the next generation to market. So we've got the silicon side, the IP side. We see test equipment from companies. I mean, very important test equipment. Let's face it. If you're going to bring an industry to market, you need to have to test it somehow. Companies like Keysight, like Protocol Insight. We see verification IP for the chip guys coming from Cadence. The cameras, it's kind of like a who's who of camera vendors who are working on bringing A-PHY based products to market. A very big announcement towards the end of 2023. LG Electronics in Korea chose our VA7000. That's our A-PHY compliant chipset to be the technology for their next generation of camera platforms. But it's companies also across the Far East, including big players like Nippon Chemicon and so many others. And at CES, we had a wall in our booth. We had a wall of publicly announced A-PHY products. And as I say, the cameras on display there were really a who's who of the camera vendors in the industry. And then it's not just the cameras. We know of satellite radar, lean radar implementations, where you take the processing from the radar, move it centrally. We've seen those from SRS in Korea, from G-Pulse in China. And even the LiDAR guys, Innovis, have a 360-degree LiDAR that are using our chipsets inside. So like I say, this is a rush to bring products to market. It's the width, it's the depth of that ecosystem that I was alluding to. And I think that is a huge endorsement from the industry of what A-PHY is, of its capabilities, and of the need finally to adopt a standard within the automotive industry.
You mentioned products and solutions. Let's talk about the Valens chipsets. Tell us
Sure.
more about that, Daniel.
Yeah, so I mentioned just briefly then the VA7000. So as I say, we are the first company to bring A-PHY compliant chipsets to the market with our VA7000 family. We have engineering samples out there now for quite a while under evaluation at many different companies, and certainly this is a technology that's gaining a lot of interest, and our chipsets are very much being tested and are in demand. The VA7000 offers 2 serializers and 3 deserializers, so 2 for the transmit and 3 for the receive side. And you know, the options there depend upon, for example, the link speed. So our maximum speed we offer is currently 8 gigabits per second, which is gear 3 of the MIPI A-PHY standard. So 8 gigabits in the downlink, 100 meg in the uplink. That's the asymmetry I was talking about. We have quad and dual deserializers on the ECU side, on the compute side. So yes, we have these chipsets. They can run up to 8 gigabits on 10 meters, which is on 15 meters of coax cable. That's just over 45 feet with 4 inline connectors, or 10 meters, 33 feet of shielded pair, again with 4 inlines. Our chipsets, which is a hugely important value proposition for them, can even run up to 4 gigabits per second on a single unshielded twisted pair. That is a unique offering, meaning that, for example, if you have a system that's Ethernet based and now you want to go to a SerDes based solution, you don't even need to change the wire harness. Okay, a really unique offering that our chipsets offer in terms of SerDes connectivity to run 4 gigabits per second over UTP. We see a lot of progress now in kind of vehicle safety, ADAS, of course, on those fronts. And we see that based upon our participation in a growing number of evaluation processes for our VA7000 MIPI compliant chipsets, and we're being validated, for example, European EMC labs at the requests of leading automotive OEMs. We're seeing outstanding results. I'm talking about EMC again. It's so important. It's not just a theory. We see it in the test results that back it up. And we already did testing in 2023 at JASPAR in Japan, which is like the Japanese automotive umbrella for their industry, the umbrella organization for the automotive industry. We had great results back then. We're seeing great results now. I mentioned, of course, the UTP support. Great EMC robustness, the most robust link on the market. These chipsets are available today for evaluation. They will be released to production later in this year. We have evaluation kits available. So yes, the technology is available today, and we are proud, very proud to be the first company to bring silicon to market for this all-important A-PHY standard.
Daniel, I always enjoy our interviews together. Your knowledge, your expertise, the passion that you bring to the table, truly a pleasure. Let's do this again, hopefully sooner than later. In the meantime, thank you for being with us. Daniel Shwartzberg, Director of Business Development and Systems Solutions at Valens Semiconductor. Daniel, look forward to seeing you in Detroit. Thank you again for being here today.
Thank you, Carl. Thank you so much.
For more information on Valens and to find out more about our upcoming events, see the links in the description or visit auto-sense.com. That's auto-sense.com for AutoSense, and for InCabin, incabin.com. That's incabin.com. And for more in-depth interviews like this, subscribe to the AutoSense YouTube channel and follow both AutoSense and InCabin on LinkedIn. In Detroit, on behalf of AutoSense and InCabin, I'm Carl Anthony. Thank you.